For number 51, we need to recognize that having an x minus 2 on the inside of the function will move it right 2, and a minus 3 on the outside will move the function down 3. So I'm going to move each point right 2 and down 3. Right 2 and down 3. Right 2 and down 3. And then right 2 and down 3. And we get the same exact shape, just slid over and down. For number 52, we have a minus 3 on the outside. That's going to move the function down 3. And then we have a 2 times 2 on the outside. That's going to perform a vertical stretch. When there are multiple output operations, I suggest using a table to make sure that you get them in the right order. In order of operations, we have an input x, and then have to take the f of that x, and then 2 times that value, and then finally 2 times that value minus 3, because multiplication has to happen before subtraction does. And our input and output values are in this first 2 pair of columns here, x and f of x values. So there we can put the original points for the function, -2, 1, -1, 2, 0, 2, 1, 0, and 2, -1. Now we can multiply each by 2. And I made a mistake on one of these. That was 0, 1. So when we multiply by 2, that's going to give us 2. And 0 times 2 is 0. -1 times 2 is -2. And now subtract 3. 2 minus 3 is -1. 4 minus 3 is 1. 2 minus 3 is -1. 0 minus 3 is -3. -2 minus 3 is -5. Our first and last columns will give you the x and y coordinates of each point in the transformed function. -2, -1, -1, 1, 0, -1, 1, -3, and 2, -5. Connect, and we have the same shape but vertically stretched and also moved down. For number 53, we have a combination of transformations. This is a horizontal flip, and the -2 on the outside indicates a shift down 2. However, if you want to deal with multiple transformations using a table of values, you can. X is our input. Then we have to take the opposite of x, because that's in parentheses, f of the opposite of x, and then f of the opposite of x minus 2. Our input and output values are the -x and f of those values. That's where our points for the original function go, -2, 1, -1, 2, 0, 1, 1, 0, and 2, -1. If -x is -2, then x is 2. And so to find the x values, we're just going to take the opposite of the -x values. And for the last column, take the f of -x values and subtract 2. And our first and last columns give us the x and y values for the transformed function. So 2, -1, and 1, 0, and 0, -1. What's happening here? Well, that's actually the opposite side of the graph that's gotten flipped over the y-axis. And then lastly, -1, -2, and -2, -3. That's the straight line portion that's gotten reflected. For number 54, we have multiple transformations also. I would suggest using a table of values. So x values, and then in order of operations, take f of those values, and then multiply that by -1. And finally, add 3 to that. Our input and output values are x and f of x. That's where the parent function points go. -2, 1, -1, 2, 0, 1, 1, 0, and 2, -1. Now moving to the right in the table, we just perform each operation. Take the opposite, and then add 3. And first and last columns give the x and y values for the transformed function. -2, 2, -1, 1, 0, 2, 1, 3, and 2, 4. So this graph has been flipped vertically and moved up 3. And that is it.